right, let's take this thing. All right, let's look at these. By the way, the second letter gives it away. Here, 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 here. Okay, L. L is liters. That's going to be volume. That's going to be milliliters, volume. Kg is kilograms. Grams is mass. G is grams, mass. Centimeters cubed. A cube of something, since they're talking 3 dimensions, is probably going to be volume. Milligrams. Grams, mass. Grams per centimeters cubed, that's a density. And then kilograms per milliliter, if something is being divided, it is going to be a density. So, there we go. Next section. Zoom in. Which of the following defines mass? The amount of matter in an object. The amount of space in an object occupies. The distance an object travels. The mass of an object divided by its volume. It is the amount of matter in the object. Volume. Volume can be defined as the amount of space an object occupies. How much space it occupies. Which of the following defines density? Density is something divided by volume, mass divided by volume. So here it is. Next. All right. What is the density of an object that has a mass of 10 kilograms and a volume of 5 milliliters? Well, we just saw in the last section, all we have to do is take 10 kilograms and divide it by 5. It's mass divided by volume, so it should be 2. Let's look at this one. What is the density of an object with a mass of 10 kilograms and a volume of 2 milliliters? Well, 10 grams, okay, and 2 milliliters. 2 milliliters, it's going to be 5. So, 5 grams per milliliter. Which of the following is most likely the density of an object that has a mass of 15? Well, 15's not in here, but it's going to be somewhere in between these two numbers. And that's 5 and 10, so it's probably like 7.5. Okay. Oh, there it is, 7.5. Cool. Using table 2, if the volume of an object is 1 milliliter, what is the density? 1 milliliter. Well, that's not on here. Well, I guess it'd be up here. And so it's going to be bigger than 20 because it goes 2.55, 10, 20. It's going to be bigger. So do I have a bigger? 30? Mass seems to be staying the same. So mass divided by volume, if it was 1, it'd be 40 divided by 1, which should be 40. 40 is the best answer. Cool. Use table 1 to determine the mathematical relationship between mass and density. Mass, 5, 10, 20, 40. Okay. Density. Are they increasing together? Increase, 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 increase. That's a direct relationship. Use graph 1 to determine the mathematical relationship between mass and density. If you have a positive slope, if it's going up, that's a direct relationship. All right, table 2 to look at mass and density. Mass, 40, 40, 40, 40, and mass and density going down. That's going to be an inverse relationship. This one's going down. This one stayed the same, but this one's going down. Okay. Oh, there it is. It's asking if it's direct or indirect. This is definitely an inverse or an indirect. So there we go. That one is done. All right, let's go to the writing section. Uh-oh, password. I don't remember the password. Let's look at it real quick. In fact, let's just delete the password. Oh, it's Nugget. All right, let's refresh it. There we go. All right. Writing section. Here's a data table. It's some of the ones we just saw a second ago. Mass, 5, 10, 20, 40. Volume stays the same. Density increases. Okay. So it's going up. It's a direct relationship. So there's a claim. Claim, there's a direct relationship between mass and density when volume remains constant. Direct relationship between mass and density when volume stays constant? Looks like that to me. So, I need to answer all these questions. Restate the claim. Well, the claim was, it's right here. Copy, paste. Next thing, support or reject the claim. Well, it's going up. It looks like direct relationship to me, so I support the claim. Appropriate numbers from the graphs or tables. So I'm just going to pick out two. When the mass was 5, the density was 2.5. So when the mass was 5, the density was 2.5. Okay. Compared it to each other. Let's do another one. When the mass was 40, the density was 20. When the mass was 40, the density was 20. I believe that's right. Mass 40, density 20. Yeah. So what else do I need? Let's see here. Oh, units with the numbers. Units. So when the mass was 5, that's going to be up here. Grams. And I go ahead and do grams for this one too. The density was 20. What is the thing for density? Oh, grams per milliliter. Grams per milliliter. Grams per milliliter. Got it. Got it? Oh, I need to say something about the constant. Wow. What stayed constant? Wow. Wow, the volume stayed at, what did it stay at? 2 milliliters the whole time. 2 milliliters the whole time. Done. Next. All right, this puppy's going down. That's inverse relationship. So there's an inverse relationship between volume and density. Volume and density. Yep, there is an inverse relationship. So did I restate the claim? Well, let's do that real quick. The claim was paste. Support or reject the claim? I support the claim. Use numbers from the graph, okay, or table. And we're talking about volume and density. So volume 2 and 20. Let's just do that. And the volume was 20. The density was, oh, volume 2, density 20. Volume was 2. Density was 20. When the volume was, let's pick another one, 16, the density was 2.5. 16, the density was 2.5. Okay. Let's see, what else do we need? Units. I need units. Volume is milliliters, ml. And density, remember from the last one, was grams per milliliter. Grams per milliliter. Got it. So, oh, stayed constant. What had stayed constant? Well, the mass remained constant. The mass remained constant at 40 grams the whole time. All right, done. All right, password should be appearing right here. Make sure you copy and paste that password and use it to get to the test. Best of luck.